We've talked about types of variables and we've talked about summarizing variables numerically. Now we're going to see, how do we look at our data? How do we visualize data? We'll start with categorical variables first, simple, nominal, and ordinal data. And these are best looked at through tabulation, putting the numbers into a table or a frequency table. These are some data that I collected when I was a student at Tufts as part of the ALE, the Applied Learning Experience. And we did a health fair of elderly Chinese living in Boston's Chinatown. And so the way we asked these questions were as nominal variables. We asked sex, male, female. And you see, in order to summarize these data, we can just put in a count, a frequency count, or we could put in the relative percent. So you can see that most of the attendees of the health fair were female. Here's a variable on work status: full-time, part-time, retired, always homemaker. I personally didn't like this category when we wrote these questions, but we said this is how this population identifies, and so this is how we need to ask this question. So again, what type of variable is this? Some sort of nominal variable. You fall into these categories, which are defined by name only. Some of these categorical variables can also be visualized in other ways. Here's some interesting data from the BRFIS, the Behavioral Risk Factor Surveillance System, and it is what percent of Americans are current smokers by state. Now, there's an asterisk here, which makes us wonder, what is the definition of current smoker? I covered it up on the bottom. What would you think a current smoker is? And what type of variable is that current smoker? It's binary, right? You're either a current smoker or you're not. And as it's defined here, you've smoked at least 100 cigarettes in your lifetime. And at the time of the survey, you smoke every day or some days. That puts you into a category, either yes or no, and it can be summarized by state. These data are a little older. It might be interesting to see how they've changed given the increased prevalence of vaping and changing laws on marijuana use as well. These data come from the Morbidity and Mortality Weekly Report, which everybody should subscribe to and get their weekly digest from them, from the CDC. The percentage of adults who consumed fruit 2 or more times, I think per day by state. What type of variable is that? How much fruit do you consume? Well, it could be continuous, right? How many grams of fruit or how many calories of fruit do you consume? It could be discrete. How many servings of fruit do you consume? And here, these researchers have gone down the hierarchy to make it into a binary. Do you consume fruit more than 2 times per day? And on the typical American, 32% consume 2 or more fruits per day. Makes me wonder, is fruit juice in that definition or not? That's an easy way to consume fruit. Here's a similar data on vegetables. Do you consume vegetables 3 or more times per day? And it looks like there are a decent amount of people who are eating a lot of vegetables, which makes me wonder if French fries and potatoes count in there. So again, these variables are turned into binary variables, but the data collection themselves is probably some discrete variable. When we think about summarizing discrete or continuous variable, now we start to see that there's a choice by the researchers and the data analysts of how they get tabulated. So here are some data from, say, an intro to statistics exam score. And on the left, we see here the distribution of these students. And on the right, we see the distribution of these students. What's the difference between the data on the left and the data on the right? There's nothing. The data are exactly the same, but how we present it is different. What categories we choose. This is called the bin width. Here we have bins of 5, and here we have bins of 10. Which one of these do you like better, the left or the right? I like this one. This one's a little easier to see the distribution, and then you could put your letter grades right on top of that. Here's some older data from cholesterol levels in the US. And I want to show this as an example of, here we have our bins here. And then here we have the frequency or the count. Here we have the cumulative count. So you add each column together to get to the total right here. Here you have the relative frequency. So 1% of men are in this category here. And then the cumulative relative frequency percentage, which sounds like gibberish, but it just means that when you add all the categories up, you get to 100% of your people. So those are some examples of tabulating your data. And here's the definitions of what we just did: the cumulative frequency, the relative frequency, which is what percent is in each row, and then the cumulative relative frequency, which adds up to 100. Now, more exciting and more fun than tabulating data is actually doing graphics and graphical presentation of data. And you can take a full course, you can read tons of books on this. We'll start with some simple stuff, which are bar charts. Bar charts can be used to visualize when you have a categorical variable. And you can either count out or do the percents of people who fall in these categories. In a bar chart, we make bars of equal width, and we put a little tiny space in between each group. So we show that there's not real numbers that are going on there. Here's a bar chart of the data we just saw, the marital status of the elderly Chinese at the health fair that I ran when I was a student. And what you see here is a count. So you can see that in this sample, there were 230 or whatever married participants. We can also take that axis here and turn it into the relative frequency. So employment status, you can see here that about 60, 70% of them are retired. Bar charts can show interesting things when we put other variables on. Here's a trend over time of the percentage of medical students who are women from 1965 to 2006. And it allows us to sort of see patterns. Here's my son, Finn. I had Finn make some bar charts when he got some candy for Easter. So here he is. What type of variable is color of candy Easter eggs? Well, it's categorical, right? Yellow, pink, and so on. And what he does is he just counts up each little box. 1, 2, 3. And when he was done, he could eat all the candy. I thought this was a great project for him. Then he did it at school too. This is part of Boston Public Schools. He brought this home. I thought it was cool that they were teaching this in kindergarten, but I gave him a hard time because there's supposed to be a space in between here for the bar charts. And then I thought, this is really weird that M&M's gets like free advertising in the kids' school in their math class. That's a different issue. Now, when we think about doing graphics for discrete or continuous variable, they are called histograms. They look like bar charts, but they're a little bit different in that each bar now is going to be touching the one next to it. And we have to make a choice of what is the interval that we're going to use. How many bins are we going to make? So here's the BMI of those residents of that health fair. And we can take a look at this. We can see where is the middle of the distribution? Where is the spread of the distribution? And what is the shape of the distribution? And we'll spend a lot of time thinking about this. Here we see that frequency is here, so you can get a sense of what number of people fall within each category. I can do that exact same data and make fewer bins. So same data, same information, same subjects, same measurements, but when I present it in fewer bins. And it's up to you to decide which one do you like better, more bins or fewer. Here's a histogram of some real data also related to that cholesterol we saw before. The distribution of cholesterol in men. You see the number of bins, you see the shape. We see some people who have a little bit higher, but then we'll spend a lot of time thinking about what is the distribution here. This is an interesting way to visualize data called a stem and leaf plot. You don't see this used that commonly, but these are the same BMI data that we used here. And what you can see is, let's say you have a subject with a BMI of 24.0. Well, you take this line right here, 24, and then you write a 0 because that person has a 0. You take another person who has 24.1 and they go here. We saw there was one person with a very large BMI. That's that person here. If you take your head and tilt it all the way to the right, like this, 90 degrees, you can see there's some sort of shape of the distribution like that. Stem and leaf plot, not commonly used, but can be very useful. Now, my favorite plot is called the box plot. The box plot is known as the 5-number summary of a variable. These are those same BMI data. And in a box plot, what you see is obviously a box, and that box goes from the 75th percentile here to the 25th percentile here. And if you think about that, that means 50% of the people live in the box, and the other 25% of people live here, and the bottom 25% live here. So it gives you a shape of the distribution. These, it's so cute, these are known as the whiskers, and the whiskers go to the highest and lowest values of the data set, unless there's a person who is more than 1.5 box lengths from the top of the box. This program actually labels these outliers or these potential outliers so that you can see that they're far from the middle. Now, this line in the middle, you might guess, it's not the mean, it's the median. So where is the middle of the distribution? So box plots we're going to come back to again and again. It's this 5-number summary: the min, the max, the first quartile or the 25th percentile, the median, and then the third quartile. And again, this is just a summary of how to read one of these box plots, or the box and whisker plots.